Students will be able to define what a matrix is. The other one is identify special type of matrices, and the third one is identify when two matrices are equal. So in our day-to-day activity, matrix is used. Matrices are everywhere. If you have used a spreadsheet such as Excel or written a table, you have used a matrix. Matrices make presentation of numbers clearer and make calculation easier to programs. For example, we may consider this table, which shows the number of masks sold in shade 1, shade 2, shade 3, in the first month, in the second month, the third month, and the first month in Awasa Industrial Park. For example, if one wants us to know how many masks were sold in the fourth month, we go along the row shade 3, in shade 3, in the fourth month, in shade 3, in the fourth month, 27 packs of masks were sold. We may also consider this number, number 10, which shows the number of masks, the number of packed masks sold in shade 2 in the second month. So directly we will go to the definition of a matrix. A matrix is simply a rectangular array of numbers or elements, rectangular array of elements. The elements can be symbolic, expressions, or numbers. And a matrix is represented by this symbol. A matrix is represented by this symbol. For example, we may consider this as a matrix. As we defined earlier, we say that it is a rectangular array of numbers or elements or etc. So in a matrix, we do have rows. For example, we may consider this one as a first row. This one is a first row. This one, the second row, the third row, the fourth row, and etc. And again, it contains columns. That means this is the first column, this one, the second column, the third column, and etc. So the ith row of the matrix A has n elements, as you can see. Look, this one, not actually this one. This is a matrix which has got, as we defined, a matrix consists of rows and columns. So this one is said to be the first column, the second column, the third column, and etc. This one is said to be the first row, the second row, the third row, and we can say the ith row. So when we come to this one, this is in the matrix. This one is this row I. It says I represents the first row or the second row or the third row, has n elements, as you can see. A, I1, A, I2, A, I3, A, I4, up to A, In. And the column, which is represented by J, that means the first column, J stands for the first column, the second column, the third column, and etc. has m elements, which is represented by this one. This is to mean A1J, A2J, AMJ. Up to AMJ. These numbers 1, 2, 3 up to m indicates what? The number of rows. And this one J indicates the number of column. Okay, what a matrix mean? Okay. Each matrix has rows and columns, as earlier we have defined. Each matrix has rows and columns, and this defines the size of the matrix. The size of the matrix depends on the number of rows and the number of columns. So, if a matrix A has m number of rows and n number of columns, the size of the matrix is denoted by m by n. Look, if a matrix has got m number of rows, m stands for the number of rows, and n number of columns, n stands for the number of columns, then the matrix is said to have a size of m by n matrix. So the matrix A may also be denoted by this one, A, then m by n, to show that matrix A is a matrix with m number of rows and n number of columns. So each entry in the matrix is called entry. our element of the matrix and is denoted by Aij. I represents our I stands for what? The rows, and J stands for the columns. When I is the row number and J is the column number. So the matrix for the mask cell example could be denoted by this one, matrix. These, as earlier we have said, the number of packs of masks sold in House Industrial Park in shade 1, shade 2, shade 3, in the first month, in the second month, in the third month, and in the fourth month may be represented by this one. There are 3 rows and 4 columns, so the size of the matrix is A3/4. The above matrix is this one, A34. This means A34 means the element that is found in the third row, that means row 1, row 2, row 3. So in the third row and the fourth column. This is column 1, column 2, column 3, column 4. So A34, it is to mean the element that is found in the third row and the fourth column, and it is 27. Then we do have the special type of matrices. Row vector, column vector, sub-matrix, square matrix, upper triangular matrix, lower triangular matrix, diagonal matrix, identity matrix, zero matrix, tridiagonal matrices, diagonal dominant matrix. Then let's define each type of matrices. The first one is a vector. So a vector is a matrix that has only one row or one column. So a matrix with exactly one row or one column is said to be a vector matrix. A vector is a matrix which has exactly only one column and one row. So again, we do have 2 types of vector matrices. The first one is row vector and the other one is column vector. If a matrix B has only one row, it is called row vector. That means a matrix with exactly one row is said to be a row vector. And a matrix with exactly one column, is said to be column vector. Row vector, for example, you may consider this one. An example of row vector is as follows. A matrix B, which has exactly one row. Actually, it has got how many columns? 1, 2, 3, 4, 5 columns. So this one is said to be a row vector because it has got exactly one row. And this one is an example of column vector because it has got exactly one column. If some rows and columns of a matrix are deleted, no rows or columns may be deleted. The remaining matrix is called a sub-matrix, which is developed from a given matrix. If a column is deleted, then the resulting matrix is said to be sub-matrix. A square matrix. The next one is a square matrix. If the number of rows and columns of a given matrix are equal, then it is said to be a square matrix. If the number of columns and the number of rows are equal, then that matrix is said to be a square matrix. Sometimes the diagonal of the matrix is called the principal or main of the matrix. We will see later. For example, we may consider this one. Look, how many rows does this matrix have? Look, 1, 2, 3. It has got 3 rows. And how many columns? Let's count. 1, 2, 3. It has got 3 columns. So the number of rows and the number of columns are equal. 3, 3. Therefore, this matrix is said to be a square matrix. And the elements in this one are said to be the name of the elements in this one. This, for example, 425, which is found in the first row and the first column. Therefore, it is said to be A11. This is to mean A11. Look, A11 is equals to, it says 25. It is to mean that the element that is found in the first row and the first column. So it is 25. Let's consider A22, which is to mean the element that is found in the second column, in the second row and the second column. So the second row is this one and the second column is this one. Therefore, 10 is or represented by A22, which is found. It is to mean that it is found in the second row and the second column. This one, 7, which is A33. A33. It is to mean that the element that is found in the third row and the third column. So the third row is this one and the third column is this one. Therefore, 7 is found in the third row and the third column. So 7 is represented by A33. So again, let's see the main diagonal of a given matrix. The main diagonal of a given matrix is a diagonal drawn from the left upper corner of the matrix, that is from this one, to the right bottom of the matrix. This one is said to be the main diagonal of the matrix. So the main diagonal of a matrix is the diagonal drawn from the left upper corner to the right bottom corner. So from this, now we will define the upper triangular matrix and the lower triangular matrix. So first, let's see the upper diagonal matrix. As we have earlier defined, the main diagonal of a matrix is a matrix drawn from the left upper corner to the right bottom corner of a matrix. So a matrix M by N matrix of which Aij is equals to 0, I is greater than j is called the upper triangular matrix. So let's consider this one as an example, a matrix A. First, we'll draw the main diagonal. Then if all the elements below the main diagonal are zeros, then that matrix is said to be the upper triangular matrix. To determine whether a given matrix is upper triangular matrix or lower triangular matrix, the first step what you have to do is drawing the main diagonal. Then if the elements below the main diagonal, that means this one, and this one, are zeros, then it is said to be the upper triangular matrix. The other one is the lower triangular matrix. Look, this. So the question is deciding whether this matrix is upper triangular or lower triangular matrix. So what you have to do is first draw the main diagonal, that is this one, from the left upper corner to the right bottom corner. Then what are the elements above the main diagonal? What about the elements below the main diagonal? As you can see, the elements in the upper main diagonal, in the upper elements from the diagonal are all zeros. Therefore, this matrix is said to be the lower triangular matrix. It is said to be the lower triangular matrix. Then is a diagonal matrix, a square matrix with all non-diagonal elements equal to 0 is called diagonal matrix. That is, only the diagonal entries of the square matrix can be non-zero. See, as you can see, if all elements, let's draw the main diagonal. If all elements except on the main diagonal are zeros, then it is said to be a diagonal matrix. Example, we may consider this one. It is deciding whether these matrices are diagonal matrices or not. What you have to do is first draw the main diagonal like this, then the elements that are on the matrix except on the main diagonal are zero, therefore it is said to be a diagonal matrix. As again, we consider this one. So as usual, first draw the main diagonal, then we'll be checking the elements beyond this one. As you can see, look, 0, 0, 0, 0, 0, 0. Therefore, again, this one is also called a diagonal matrix. We may consider this one again. Okay, not actually a diagonal matrix, it is identity matrix. A diagonal identity matrix is a diagonal matrix. Look, an identity matrix is a diagonal matrix in which all elements in the main diagonal are ones. Is it clear? An identity matrix is a diagonal matrix. Look, the matrix first must be a diagonal matrix, and the elements on the main diagonal must be what? 1. The elements on the main diagonal must be 1. So let this be enough for today. We'll proceed to will come with the next lesson. For today it is enough. Thank you very much.